this video, we will look at function composition. In basic terms, function composition is the result of placing one function inside of another function. Algebraically, we write y equal to f of g of x, which is just a way of writing f of g of x. When we do this, we get a new function. We will look at examples of function composition by hearing and seeing what is called a sine function. Even if you have never taken trigonometry, you actually see and hear sine functions all the time, since light and sound are made of a whole bunch of sine waves, which are the graphs of sine functions. We will look at a simple sine function and its graph to start. Here is the graph of y equals sine of x. Some things we can note. The amplitude of this graph is 1. The distance from the middle to the top of the wave is 1 unit. You can see that by looking at the middle of the graph and just going up to the top and see that that's 1 unit. The frequency is 1 over 2 pi. What this means is that one cycle of the graph occurs every 2 pi units. If we start here and follow the curve, we'll see that it ends after 2 pi units has gone by. Let's compare this to the graph of another sine function, y equals sine of 5x. You can see that this graph has the same amplitude, but there are a lot more peaks to the wave. This is because the frequency is now 5 over 2 pi, which means there are 5 cycles every 2 pi units. To see this easily, just notice that there are 5 times the graph is at its highest value when we're looking from x equals 0 to x equals 2 pi. And now let's look at a composition we can make with these two functions. In this case, y equal to sine of 5 sine x. What I have done is replace x in y equals sine of 5x with the first function, sine of x. When we do that, we get the graph that's below. The shape has dramatically changed, but if you look closely, you'll see that the frequency is the same as y equals sine x. We've created a new function by putting one function inside of another, but there is still a relation to the ones that we started with. To explore these new functions further, let's turn to the synthesizer. On this particular synthesizer, I can create a few different sine functions that we will be able to hear. There are two things that we will need. The frequencies will need to be high enough for our ears to detect them. This is possible for frequencies between 20 Hz and 20,000 Hz, which is the same thing as 20 kilohertz. Hertz stands for 1 cycle per second, so 20 Hz means 20 cycles per second, and 20,000 Hz mean 20,000 cycles per second. These frequencies will relate to the pitch of the note that we will hear. Different frequencies have different pitches, like different keys on a piano. With these units, we now have set time as the horizontal axis for the graphs that we'll see. The second thing that we'll need is the amplitudes for each will need to be the same. On a sine wave, amplitude relates to the vertical distance from the middle to the top. In simple terms for our graphs, the vertical axis will be voltage, and the higher the voltage of the wave, the higher the volume is. Think about how these words of amplitude, or amp, and volume relate to listening to music on a stereo. These sine functions are located on what are called oscillators. The word oscillator refers to the back and forth nature of electricity and alternating current, which is what is powering the synthesizer. There is a knob on the oscillator that can be used to set the frequency. I'm going to have one oscillator set to 110 Hz, and the other one will be set to 550 Hz. If you are familiar with a piano, 110 Hz is the second A below middle C, and 550 Hz is just about a C sharp, a little more than an octave above middle C. I chose these two frequencies to relate them to the first two sine waves that we saw, where one had a frequency 5 times the other. Let's listen to them and see their graphs on the oscilloscope. So first, the 110 Hz sine wave. And next, the 550 Hz sine wave. But I'm going to have both sine waves displayed on the same graph. The top one in green is the 110 Hz wave, and the one at the bottom in blue is the 550 Hz wave. Notice how many more peaks there are in that wave. And while we have this sound going, I'm going to place the 110 Hz sine wave inside of the 550 Hz sine wave. Notice how the sound changes when I do that. You can also see that the graph in blue has changed shape. Now that we understand the basic idea, let's experiment with different functions and compositions. First, I'll take another sine wave with frequency 50 Hz and place it inside the same 550 Hz wave that we've been looking at. Notice how different this sounds when compared to the 110 Hz wave. With function composition, we can use any function we want, not just a sine function. So with this next example, I'm going to take a function that I used in another video and use it to change or modulate the pitch of this same 550 Hz sine wave. And for the last example, a musical application, vibrato. This is an effect used by a lot of singers where the pitch oscillates around a particular fixed pitch. The way that we can achieve this effect on a synthesizer is by lowering the frequency and amplitude of the function we place inside of the function holding the particular pitch. Here I have placed inside of the same 550 Hz sine wave another sine wave with frequency 6 Hz and amplitude at just 2% of normal, so very low frequency and a very low amplitude. The low frequency of this wave is given a special name on synthesizers, an LFO, or low frequency oscillator. Here is a piece that was recorded using synthesizers where this vibrato effect was used to help the instrument mimic a human whistle.